Okay, seriously, plastic is like, it's everywhere. You look around and it's in your coffee cup, your phone case, even parts of our furniture.
It really is amazing how integrated it's become.
And you all asked for a deep dive into the different types. So let's do it. Today, it's thermoplastics, thermosetting plastics, and elastomers.
We'll break down not just what they are, but like what makes each type so well suited to its job.
Yeah, because, it's not all just plastic. It gets
Yeah.
pretty wild.
It does. The variety is actually pretty fascinating. We use so many different kinds daily without even thinking about it.
Let's start with, I think of them as the, like, chameleons, the thermoplastics. They're recyclable. You can mold them. It's almost like a superpower.
Right. That's all about their molecular structure. Imagine these long chains of molecules that can kind of slide past each other when you heat it up.
Oh, okay.
So they soften with heat, harden when they cool, but the chemical structure itself, that doesn't change. So melt them, reshape them multiple times. They're the ultimate recyclers, I guess.
That makes sense, like melting candle wax and remolding it,
Yeah.
but way more high-tech, right?
Exactly.
So examples,
Mm.
what about, like, everyone had Legos growing up, those iconic bricks. What are they made of?
Oh, great one. Legos. Those are ABS, acrylamide butadiene styrene. And it's got this crazy impact resistance.
Which explains why stepping on one is so memorable.
Yeah, exactly. It's designed to take a beating. Both your foot and the brick survive.
They really do last forever. Okay, what about something more see-through? Like, those huge aquarium tanks?
Those are often acrylic. Polymethyl methacrylate, technically, known for being super clear and weather resistant too.
Oh, right, because you see acrylic signs outside, too.
Exactly. Partay lights, even. It's versatile because you can shape and polish it easily. So showing off, I don't know, exotic fish to vintage cars, it works.
Wild how much stuff comes from just one kind of plastic. But speaking of versatility, I was reading that polypropylene, that's like a workhorse, right?
Totally. Polypropylene, or PP, it's lightweight, it stands up to chemicals, and the fatigue resistance is impressive. Think about those little living hinges on, like, a shampoo bottle.
Wait, yeah, they through a lot of use.
Thousands of openings and closings, no problem. That's polypropylene at work.
I never even thought about the science behind a shampoo bottle hinge. Now, onto one that I know gets some bad press, polystyrene.
Oh, yeah. Polystyrene is actually incredibly versatile, though. You can have it rigid, like disposable cutlery, or foamed, like packing peanuts.
Oh, that's all the same stuff?
It's all about how it's processed. But its key traits are being lightweight, great insulator, so perfect for protecting fragile things when you're shipping them.
Makes sense. It's
Yeah.
kind of cool how one plastic can be so different depending on, like, how it's made. And speaking of variations, polyethylene, that's another one with a split personality, I feel like.
Totally right. Polyethylene, you've got high density, HDPE, and low density, LDPE. Easiest way to think of it. HDPE is like a sturdy milk jug. LDPE is your flimsy grocery bag.
Okay, so rigid containers versus flexible films. Same base material, though. Got it. What about PVC? That's in pipes, but also, like, medical tubing.
PVC, polyvinyl chloride, super durable stuff. Stands up at chemicals, weathering, and you're right, can be flexible or rigid depending on what they add to it during production.
So, yeah, plumbing to healthcare, pretty big range.
Huge.
But I also know there's this whole debate about it being, like, environmentally not so great.
You have to bring that up, definitely. It's super useful, but some of the additives that make it flexible can be harmful. And recycling it is complex, so it's not always as simple as good plastic, bad plastic. It's about understanding, like, the whole life cycle. It's definitely true each material comes with its own environmental, like, baggage you got to consider. That's why they keep doing research, trying to make things more sustainable, you know?
For sure.
But speaking of different challenges, thermosetting plastics, those are a whole other category.
Right, if thermoplastics were our chameleons, these are more like the tough nuts, huh?
Yeah, good way to put it.
Like, once they're molded, that's IT. They're set for life. Which makes me wonder, how are they even useful if you can't melt them down, reshape them, like we talked about?
It's a good question. So thermosets, they go through these irreversible chemical changes when you mold them. It's like, imagine baking a cake. You can't unbake it,
Makes sense.
but that permanence, that's what makes them perfect when you need something super durable, heat resistant, that kind of thing.
It's all about matching the material to the job.
Yeah.
Right. So what kind of jobs are we talking? Like, I'm picturing those sleek countertops you see in kitchens now.
Oh, yeah, you got it. Those could totally be melamine formaldehyde.
Ah.
That stuff is, like, incredibly hard. Strong, heat resistant, chemicals don't bother it, scratch proof. They use it for laminates all over, not just kitchens, furniture, flooring.
It's crazy going from this liquid resin to a surface that tough. It also makes me think of like old electrical fittings, the kind that just seem to last forever.
Probably urea formaldehyde, what you're thinking of. It gets a bad rap sometimes because of the whole formaldehyde thing.
Yeah.
But when it's bound up in urea formaldehyde, it's pretty stable, safe to use, and it's got these fantastic electrical insulating properties. So for things like fittings, components where safety matters and you want it to last, it's essential.
So even a material that has like potential downsides, when you handle it right, it can be crucial for certain things.
Yeah.
That's interesting. Okay, we've done moldable, we've done steadfast. Time to stretch our imaginations now. Literally, elastomers,
Hmm.
the flexible friends of the plastic world.
I like that, yeah. Elastomers, what makes them special is you can deform them under stress, but they bounce right back to their original shape, this elastic memory, they call it. So anything needing to be flexible, resilient, it's perfect. Imagine a world without rubber bands or car tires. That's how crucial this stuff is.
And tires, that brings us to like OG rubber, right? The natural stuff. Kind of amazing that tree sap led to something so huge for transportation, industry, everything.
Right. Natural rubber, been around forever, still used tons today. It's super resistant to abrasion. That's one key thing. So footwear, conveyor belts, all that. But also it's biocompatible, meaning it's good to use for medical stuff. Gloves, tubing.
It's wild how versatile nature can be. But we've also made some pretty awesome synthetic elastomers, like silicone rubber. That's got to be up there.
Oh yeah, silicone rubber is like the extreme athlete of elastomers. It can handle both super high GH and super low temperatures without falling apart. That thermal stability is amazing. Think about those silicone baking molds. Freezer to oven, no problem.
That's why I love them. Nothing sticks, plus you've got to worry about melting. And then there's polyurethane. That's another one I see every day. Couch cushions to the wheels on my suitcase.
Polyurethane, it's a jack of all trades, truly. Flexible A&Ds, strong enough to bear loads. So, comfy seating on one end, heavy-duty industrial wheels on the other. Plus, it's in coatings, sealants.
Wow, from natural rubber to all this synthetic stuff. I guess flexibility and being able to bounce back, that's kind of crucial in a world where everything's in motion, always being used. But I got to bring it up. With all this amazing plastic we've talked about, we can't ignore the elephant in the room.
Oh, absolutely. The environmental impact, it's huge.
It's a big one. We've talked about how versatile plastic is, how it's in everything.
Yeah.
But the downside, the impact it has. You
Yeah.
can't just sweep that under the rug.
Absolutely not. It's kind of ironic, the very thing that makes plastic so useful that it lasts so long.
Yeah.
That's also what makes it a problem. We got to get rid of it. Tons of plastic takes centuries to break down, and we're just churning it out constantly.
Right, and it's like, we need stuff to last, but then it ends up in landfills, the ocean. We all know recycling's important, but it feels like barely making a dent.
Recycling is key, but it's not the whole solution. Some plastics, just super hard to recycle. And the process itself takes energy. Plus, getting people to sort it right, contamination, it's complicated.
So is there even like a good path forward? We need this stuff, but we also need to, not crash the planet.
That's the million-dollar question. I think it's got to be a multi-pronged approach.
Yeah.
We have to rethink how we even design plastics in the first place. More focus on recyclability from the get-go.
Okay, so like built into the process, not an afterthought.
Exactly. Using recycled content whenever we can. And this is where the new stuff gets exciting. Biodegradable plastics, compostable ones.
Like those are starting to like pop up more and more.
It's about closing the loop.
Yeah.
Plastics shouldn't be ending up as waste just out in the world.
That makes sense, but it sounds like it's not just companies that have to change. Like, as consumers, are there things you can do that actually make a difference?
A ton. Being mindful of what you buy, supporting companies that are doing things right, sustainability-wise, cutting back on single-use plastics, obviously, and then, just recycling properly. It all adds up.
So it's like every choice matters. From what you grab at the store to how you toss it out later. It's a lot to think about.
It is. But hey, next time you're holding something plastic, appreciate how clever it is that someone invented this stuff, but also think about where it goes next. Be a part of making it better.
That's a good takeaway. Well, this has been a wild ride. From the tiny molecules to these huge issues, plastic is way more interesting than I think most people realize.
I agree. Hopefully everyone listening, they've learned a bit. Maybe they feel a little more empowered to make good choices going forward.
Thanks for joining us for this deep dive into the world of plastics. It's definitely more than meets the eye.